What's up, everybody? It's been a hot minute since I made a YouTube video, and I figured what better way to come back to the channel than doing a reaction video on Jankbu's. I built a modular cyberdeck. Now, I haven't watched this video at all, but I've been seeing a lot of VTubers doing reaction videos, and I'm a tech nerd. I love tech. Tech has always fascinated me, and I've always loved the idea of building a cyberdeck, a cybercomputer, a specialized form of cyber optic device, whether that be like a wristband with a monitor on it that you can tap and like do what you do, almost like a smartwatch, but like bigger and with like Kali or one of these like cool distros in it that let you do basically crazy things. Anyways, without further ado, let's get into the video and let's see what he's got going here and figure out what's going on.
I needed a new computer, but buying a modern computer just didn't feel right. So I built this. A modular cyberdeck with a sliding screen, battery power, trackball, and a rail system so I can mount it wherever I want. I use it for 3D modeling, accessing blueprints, browsing the internet, and it goes where I go. It's not finished yet, but this janky little machine already starts to feel like a part of my toolkit.
So, one thing I want to break down with this is it's definitely very big. So, like, if we go back here, right, where it shows him, like, walking with it, like, him walking with it alone, like, right here, right? Like, that's big. That takes up a lot of space, and it's definitely not very covert or stealthy. Honestly, like, you could arguably kind of just put a tablet there and kind of get the same results. So, like, I'm almost wondering, like, is it just like, is there anything special to it, or is it just, just kind of basically a tablet with a keyboard? All right, let's keep watching and see what they got.
It's not finished yet, but this janky little machine already starts to feel like a part of my toolkit. I built it because my computer is my most important tool. But looking for a new laptop, I kept getting this feeling that you don't fully own a modern computer anymore. Sure, you can pay for it, take it home and use it every day, but it still doesn't really feel like it's yours, because you're not really meant to open it, upgrade it, or even repair it. In the workshop,
So, I actually have comment on this too. I do agree with many of those tech videos, those tech YouTubers, this guy in particular as well. A lot of the ones that do the YouTube shorts. Laptops, especially now, not that they used to really be upgradable in the past, but it feels like now they just make it harder and harder to upgrade laptops. And yeah, there are some companies that are going out there to fix this issue and allow easier access to upgrades. But it doesn't solve the overall like problem unless we were to get them more in the public's eye. Because currently a lot of companies, especially Mac, for instance, they will go to great lengths to ensure that you don't modify any of their computers, not even just laptops, desktops too. But I do think that all computers, including laptops, should be 100% modular and fully upgradable, just like a lot of desktops are. Now, let's continue back to this.
my relationship with my tools is completely different. One of the first things I had to do in my apprenticeship was learn how to build my own tools, and that experience stuck with me. There's just something almost primal and very satisfying about taking raw material and shaping it into a tool you then use. It becomes mine in a way that makes me trust it differently, even though you could probably buy a better one at the store. So I started wondering, what if my new computer could feel like that too? Not by making the chips from raw silicon, obviously, but by combining existing electronics and shaping everything around it into a computer I could repair, upgrade, modify, and actually call mine. That idea already has a name: Cyberdeck. It stems from old cyberpunk fiction, but today it means a custom portable computer built around the way you actually want to use it. Mine started simple: a Raspberry Pi, Linux, small screen, keyboard, and trackball. I'd never really used Linux before, so this was mostly a test.
This is pretty neat. Obviously, you wouldn't want to have all of this kind of dragged around with you. So it's going to be neat to see how he did the housing, whether he 3D printed it or if he like custom like made it without a 3D printer. But yeah, you definitely wouldn't want just all of this hanging about. And yeah, let's see how he did that.
Could I actually get work done on a Linux computer? I installed FreeCAD, opened some blueprints, did some browsing, and it worked. Not perfectly, but enough that I started thinking, okay, this might be possible. But it wasn't something I could carry with me yet. So I had to build it a body. Although I spend hours each day doing 3D modeling, I love prototyping with cardboard. Laying things out, drawing, cutting, adjusting, gluing, figuring out what makes sense for me. But most important of all, cardboard does not let you lie to yourself. If you start 3D modeling right away, it is very possible to draw up something that cannot work in reality. But with cardboard, as you shape it and hold it, you very quickly find out what does and does not make sense. At first,
that's a cool concept, because I would assume that a lot of people would use like paper or get schematics. I've never seen someone use cardboard in this way. And honestly, it kind of gets me a bit excited because I'm now thinking of ways that I can do this. Yes, ways. But yes, so I'm now thinking of different things that I might be able to actually do using cardboard as like a placeholder. So this is a really neat idea.
Device had a flip-up screen, but I realized I had just built another laptop. So I tore it apart and tried a sliding screen instead. And that was the one change that kind of set the direction for the whole project.
One more small tidbit. Technically, okay, so yes, if it folds out, it technically is just not the laptop. However, well, like, I'm thinking, right? Because, like, I guess size would maybe matter too. No pun intended. Not that size. No. Bad. Bad. No dirty thoughts. But what I'm thinking is, right, is like, depending on how the screen is, you could do cool things even if it still just opens. So, like, I know this is a bit different, right? But let's say I want to make a wristband. I could make a foldable screen that just kind of slaps onto the wrist, like one of those toys that you could like hit your wrist and just slaps around like bracelet, but like with a screen, and then boom, portable like wristband computer, hacker computer, pew pew, yeah. Anyways, continue.
From there, I did the rest of the design in CAD. Having the physical mockup made the 3D model feel grounded in reality, just like I was refining something physical. I started building out the sliding mechanism, but the more finished the concept became, the more it started to feel wrong. It looked good, but it did not leave much room to change with my needs. So I grabbed a saw and chopped it up, turning it into a core system with modules I could swap in and out. I used Arca Swiss plates and clamps to test how swapping on and off modules from the Cyberdeck could work, and I loved it. This was no longer one object, it had become a system.
I mean,
I implemented the change into the 3D model, splitting the model into separate modules, just like the cardboard mockup. A trackball will give me a compact way to move my cursor the handle have a integrated scroll wheel. The external connection module will allow me to connect other devices to the Cyberdeck with these twist connectors, and the power module accept commonly available NPF batteries. At that point, the cardboard had done its job, so I retired it, leaving the 3D printer to take over prototyping, producing parts
Rest in
with
peace,
far
the
more detail
cardboard.
than the cardboard ever could. This project went through a lot of iterations. First,
Yeah.
very rough dummies of the modular attachment, and then the chassis itself, letting me test fit hardware.
You know, isn't there like a way to melt down all that excess plastic and reuse it as like more filament? Because like I'm pretty sure like 3D printing filament is decently expensive, so I would assume they would have ways to reuse it if like some of the creations didn't go the way they wanted. I mean, depending on the filament, I know there's different types, but I would assume he's using at least some quality level filament.
The first printed prototype was beyond crude. I printed it with the coarsest setting and assembled it with whatever hardware I had scavenged away. But it did what it needed to do. It let me verify the measurements and test fit off-the-shelf components. On the cardboard model, the mounting interface was based around Arca-Swiss dimensions, but those parts are large and expensive. So I scaled everything down to the smaller NATO rail standard instead. The rails themselves were printed in plastic, strong enough for this application. With rails in place, the modules could be slotted in, and I could haul the first prototype. It's a deeply satisfying feeling to hold something that previously only existed inside the computer. But that feeling did not last long. You see, on the next prototype, I had moved on to the sliding screen.
Yeah, because also another thing too, I would be kind of like concerned because depending on the weight of it or depending on how strong the actual filament is, could filament like that break easier than like plastic? Or is that plastic? Like, I just, I don't know. I wonder like how durable it would actually be because like, let's say you're strapping it to the back of your person like he was, right? And let's say you trip or you fall or something and you land on it. Yes, plastic can break, but durable plastic would have a lot harder of a time breaking. And I'm just wondering if it's as fragile as that or if it's like more durable.
That's when things got difficult. I started with 3D printed glide bearings. In CAD, they made perfect sense. But in reality, they never really worked. One prototype was too loose.
Yeah, I can
So
see that.
I tried beefing up the rails in two ways, adding more lateral support and more screws. But that prototype ended up too tight, with the mechanism binding and flexing while trying to slide it. And just as I was getting frustrated, I found another problem. I had spent so much time thinking about the sliding rails that I had completely forgotten about the wires that had to move with them. Every time the screen slid back and forth, the cables were getting pinched inside the mechanism, and now the whole project seemed like a failure.
You know, one thing he could do too, as like a side note, just like back to this where he's doing the whole sliding thing, right? One thing he could do is he could have it set up, sort of like how you see these ridges here, where you could have it go like up, 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 so it like latches on, or when it gets to the end, it like latches on, and then you disengage the latch to slide it down. Because it would be kind of annoying, right? Like, let's say you're using it and it just slides down. Like, let's say you're just kind of like using it at an angle and the screen just keeps coming down like towards your hands as you're typing. Maybe I'm overthinking it.
Project seemed like a failure. So I had to go back to the drawing board, redesigning the whole sliding mechanism, carving out space for these proper linear bearings.
Also, side note too, like one thing that I always hear, and this is good for any of you that might be struggling with like building things or writing scripts or anything in cybersecurity or even just gaming, like in general, right? One thing I always get asked is how do you make the programs you do in Python? How do you make these amazing programs? And I find it so funny because not only is the program they're looking at not even close to the first iteration, it's probably the 50th or 100th iteration of what it originally was. Like, I'll recode the same program over and over sometimes. Some might call it insanity, I call it experimentation. And it makes you think about it because each time you recode it, don't recode it the exact same way. That's boring. Try different ways, try different methods, test out different things, and see if you can make it less lines of code or even more efficient than you did the last time you coded it, and go from there. Because every little iteration you can reuse in other projects from what you learned on just that small little piece of code that you worked on. So it may seem insignificant by itself, but it does stack up a lot. So don't give up because something's hard. It just means you haven't done it enough, or, you know, you just haven't gone through enough iterations. And trust me, there have been plenty of times where I've looked at things and gone overwhelmed and even tried to sleep, but I can't sleep because then I have nightmares about not getting it done. Not even nightmares, just dreams about not finishing it. And then I'm like, no, I can't sleep. I gotta finish this. I gotta get it done. I gotta try again. But definitely do take small breaks and then go back at it and try it again. And in this case, the same concept applies here because if we go back just a moment, he's going through so many iterations of this and retrying new and new things until they work. And that's just life. That's cybersecurity. That's gaming. That's everything, right? Not one way will work for everyone. You just have to keep trying new iterations until you finally get something that works and then improve upon that.
Carving out space for these proper linear bearings. And for the cable issue, I downloaded this cable chain, just like the ones you see on CNC machines, just smaller. I modified it to fit within the chassis.
That's a
And
cool way
talking
of
about
doing
the chassis had now been split into 6 main parts that, when assembled, locks the large linear bearings in place. And the side rails for the modules now have locating slots for perfect alignment of the expansion modules. The linear rods for the bearings were really heavy, so I first tried cheating by saving weight with these lighter fiberglass rods.
So, notice something. He first tried cheating. Notice, like, yep, there have been plenty of times when I've tried to cheat my way through specific programming or specific things, and it can work when it wants to, but it's not a good habit long term. And I'm assuming that's why this is his first try at this.
But they weren't precise enough
Yep,
and just tended to bind up.
yep.
So I
And that's the other thing too. You got to keep in mind. So looking at this, right? Obviously, it should be pretty obvious what's going on, but if you don't know, one of the biggest problems with this design is it just has 2 points of contact. So, because this is a very long rod, no pun intended, it's very easy for it to bend outwards and then add drag or resistance. There's no track or something keeping it straight. There's no second set. Like if there was a second set of these down here, it would go a lot smoother. But even then, you're still going to have some drag because it doesn't really have that track for it to go on. It needs a track in it, and it's still preferable that there's 4 points of contact, not just two.
had to switch back to steel. Heavy, but reliable. I had also included a screen lock built into the chassis to hold the screen in open position.
And see, even though there's 1 point of contact here, the steel is a lot smoother, and it just it's going to go a lot better, but he still really should have added another point of contact. Like, I know it's hard because you still want the keyboard here. I wonder, because like there's definitely ways he could do this, right? Like I'm trying to think, because now my tech brain is exploding. Okay, so let's assume that. Okay. Hear me out, right? Instead of this rod at all, right? You can add multiple cylinders in here that extend with it. Okay, like they extend out when this goes out, and they extend with it, and they have the rod as the centerpiece, like holding them firm, but just hollow rings in here that all extend with it and cover the rod. That would also by itself add another form of stability, because like I'm not sure how well I would trust these if it were to like fall, these being by themselves. But yeah.
Okay, time to fit the cable chain. And look at that. This time, the liner movement is smooth, and the cable chain
Okay,
will
now I feel a
protect the
little dumb.
cables.
I didn't see the liner
At this
chain.
moment in the design process, I was still playing around with what features I wanted in the final product. I added some configurable buttons and a deployable antenna around the screen for some extra cyberpunk flair.
I would also hope that he labels these buttons, because if you don't label them, yeah, kind of like Russian roulette with your computer.
Later, I want these buttons to act like shortcuts for tools in FreeCAD. When the screen assembly finally moved smoothly and the cable chain followed along without any snagging of wires, that was the first time I really felt this might actually turn into something usable. And I got the motivation to do the final push,
I agree,
using
it's looking
everything
very
I've learned
good.
from the failed experiments to finally lock in the design. One of the last major design changes was adding 2 additional rails at the bottom of the chassis, acting both as a mounting system and for transferring data and power between the central unit and the modules. Now I could print the parts in a more durable and permanent material. This was the version I've been working toward all the time. These final parts had the industrial cyberpunk vibe I wanted, and it was time to bring it all to my local makerspace for the final assembly. The parts are printed in polycarbonate with chopped carbon fiber strands. This plastic material withstands heat, so I can leave the Cyberdeck in a hot car without it distorting.
So that is good, and something like this would be good because you do want to focus on heat. However, like, let's say you were to buy something like this, right? I'm not saying he's selling it or anything, but let's say you were to buy it. That doesn't mean you can just leave it under your pillow, like some people do. There is very high chance a fire will start, because at the end of the day, yes, these are fire resistant, but these are still vents. They still need to have air exit and enter. Under a pillow, it's very hard for that to happen. So the reason why I bring this up is because there have been situations where people have bought a laptop and they read that it was fire resistant. So they assumed, oh, I'll just chuck it under my pillow. Not a good idea. Not a good idea. Just, you still got to have safe practices with it.
From the heat, and the carbon fiber makes the parts stiffer and more dimensionally accurate, but at the cost of added brittleness. This time I really had to consider the order of assembling the parts, because there will be wires going between the electronics. I started wiring up the essentials first, focusing on power delivery so I could boot up the Cyberdeck. On each prototype I had gotten the tolerances around the keyboard tighter. Now it just snaps perfectly into the Cyberdeck. Screws then secure it to the chassis. This thing will convert battery power to the 5 volts the Raspberry Pi needs. 2 wires for power and 2 for the power button. Now I can install the actual brains of this project, the Raspberry Pi 5. I had to remove some of the heatsink to fit the power module, which is not optimal, but it should be fine. I tried to keep the soldering to a minimum using standard USB cables. Soldering directly to the board could save a lot of space, but I would rather have it this way for a quick replacement of the Raspberry Pi.
100%. And cables break all the time.
The soldering
so
didn't go well and ended up a little janky, and I had to isolate it with some tape. But after connecting a power supply, I could hotwire the Raspberry Pi start button. And
Also, side note, just for everything, yes, it may come out a bit messy. Like he is talking about how it came out a bit messy. Don't worry about that. Even to him, if he happened to see this video, don't worry about the mess, right? Because here's the thing, right? Your first iteration, it doesn't have to be perfect. It just has to work, and it has to work reliably, and it has to be safe. As long as you can make it safe, reliable, and work consistently, you're good. Then every iteration after, or every small improvement, you can just keep adding to until you get a final product that does look fancy and good as well. But the first iterations are never going to be perfect. There's been tons of code bases I've worked on. I know that's a bit different than this, but they've had way more lines of code. And then I looked back at them years later and I'm like, this is horrendous. I could have made this in so much less code. I could have saved myself so much less trouble. But, it's just stuff you learn over time.
the computer lit up, confirming the wiring was correct. Now I could move on with plugging in the cables going to the screen. The cable chain transfers signal through a flat ribbon cable and power with a 2-pin cable. At the end of the ribbon cable is a normal HDMI plug. The carbon fiber.
You will also find out that I hate ribbon cables with a passion because manufacturers tend to put them in the worst spots where, like, when you're opening something up, like, if you're not focused or you're not properly doing it, you could just snap the ribbon cable and it's not fun. It's not fun. I don't like them, but I understand their necessity and I understand their use.
Material was especially important for the large parts in the screen assembly. Here, the trade-off in brittleness is worth it for the added stiffness. The buttons around the screen were installed but not hooked up to anything yet, as I have not decided where I will wire them. The screen, however, is simply plugged into the HDMI and power. After mounting the screen to the frame, I could boot up the system again. For the first time, the screen lit up, and I could test the sliding mechanism and the keyboard. The weight of the mechanical keyboard balances out the weight of the screen, so the Cyberdeck is heavy but surprisingly comfortable to hold. The core system was alive.
I think it looks
but
very
still
good.
Connected to external power. To make the Cyberdeck complete, I started working on the expansion modules that currently were just hollow dummies. I spent the next month turning them into real input devices to be able to use my Cyberdeck. And that meant more prototypes. And just like with the chassis, each prototype fixed one problem and revealed the next. I started to realize I couldn't finish everything at once. So, after locking in the aesthetics of each module,
take it in parts.
I shifted my focus to just making the battery module and the trackball module functional. The handle and external connection module could wait. First, the battery module. It is very simple, only transferring power from a NPF camera battery and power on signal into the deck. I got that working and added some simple indicators for voltage and battery orientation. With the power module functional, I could finally run the Cyberdeck off a battery. That felt like a big step forward, but I still couldn't control the cursor. So the next step was getting the trackball working.
That might be a small problem.
And the trackball. That took a lot of work. I went through a lot of iterations, different ergonomics, ball sizes, button layouts, just trying to get something that felt right. In the end, I used the internal parts from a Logitech Trackman marble. Because
also, fun fact for those of you who were born more recently, you're lucky. You never had to experience this, but mice nowadays, they use the laser that you're all accustomed to, or most of you would be accustomed to. But that wasn't always the case. A lot of them used to use a little ball that rolled around, and a good portion of you probably know what I'm talking about, but like, when I grew up, we actually had one of those mice that would use the ball. And this is kind of what it reminds me of. But I'm hoping he won't control everything with the ball alone. Like he'll have like some form of like something. Because, like, what if the ball falls out of its enclosure? Is he gonna have it, like, in there properly? Just,
Designing a PCB from
it'll
scratch
be fun.
was a bit out of scope for now. I soldered extension wires into the original board and connected them to industrial buttons to get some proper tactile input. The soldering wasn't great, and the wiring got pretty cramped, but I got it all put together in the end. Since the handle and trackball module also serve as mounting points for a shoulder strap, I didn't
That's smooth.
entirely trust the printed plastic to carry all the weight.
Yikes.
So I decided to machine those parts from aluminium instead. If you want to build this yourself, but don't have access to a lathe, you can download the CAD files
Isn't
from
aluminum
GitHub
supposed to be
and
weak?
have them manufactured through this video's sponsor, PCBWay. I tested their machining service, and compared to the parts I made myself, the quality was spot on. Shipping was fast, packaging was solid, and it's a great option if you want metal parts and you can't machine them yourself. I like how the contrast between the rough printed parts and the smooth machine metal came out, and I can recommend using PCBWay. Ordering parts from PCBWay are almost like slicing a 3D print. You just upload the file, select quality, and hit go. Let's get back to the build. To be able to connect all the modules to the central unit, I had to solder up these custom wires.
Solder.
They have connectors that will mechanically lock them in place, while still being easy to swap in and out. Soldering these connectors were not easy, but eventually I could put together a full Cyberdeck. At this stage, only the power module and trackball is functional. The handle and connector module is still not working, but that does not matter yet. Now I was just excited to give this system a proper test. Battery in, boot sequence start. And for the first time, I could actually use it.
It's alive!
But can it perform as a usable tool, or is it just a fun toy? That remains to see. It was getting late, so I had to wrap up, and on my way home, I got to test the shoulder strap.
Sleep is for the weak! No sleep!
The next day, I brought the Cyberdeck with me to work to see if it would actually hold up in daily use. I mounted it to the machines using the rail system. And I pulled up the blueprints and schematics I needed.
I mean, it looks sturdy. I would
On
say
my break,
that
I used the
looks
Cyberdeck
really
to
good.
browse the news. After my break, I had some milling to do. So I clamped the deck to the milling machine and got to work. And at some point, I stopped thinking about it as a project. It had become just a tool, just like the other tools around the shop. Just there, doing its job. It's not finished yet. There are still things I want to improve, like the handle scroll. It's not wired up. The external connections and the buttons
But
don't
it all
connect
comes
to
with
anything, and I'm getting a low voltage warning occasionally. But despite all that, this Cyberdeck already does everything I wanted it to do. It feels like a tool built for me, not something I'm just allowed to rent, but something that's actually mine.
And, like, this was obviously a really cool video, and I really think that this guy, Jankbu over here, I think that he made an amazing project. And one thing I will say is, in life, whether it's cybersecurity or anything, right? The tools you use might not always work for you. And that's fine. There's nothing stopping you from going in, making a new tool. You're going to hear people say, oh, don't reinvent the wheel, don't do this, don't do that, right? Don't listen to them. Yes, in some cases, you shouldn't go out of your way if something works perfectly fine. However, if you genuinely see an opportunity to improve it, if you genuinely see a way that it can be made better, then do it. The whole saying, don't reinvent the wheel, means don't recreate the entire thing from scratch. It does not mean that you can't improve it. It does not mean that you can't make it better. Anyways, we're drawing to a bit of a close. I hope you all enjoyed the video. If you did, let me know. Slap the like button and subscribe. And of course, leave a comment down. If you want more videos like this, just let me know. And also be sure to check out Jankbu's channel. A link will be in the description. And go give him a follow, go give him a like, subscribe, and thank you all, and y'all have a good one. Peace out.